Okay, so in our last class, we were talking about the features and we started with our first C++ code. So what we can summarize in terms of C and C++, that the C features like function declaration, then loops, these are basic C features which are there in C++. Apart from that, we have got the feature of encap exception handling, okay, encapsulation, then access specifiers, the use of private, public, and all this. So this is a feature that uh, got added. Then the templates were there, which we found that it is a kind of polymorphic feature where the classes can be polymorphic. So, and then there is other kind of polymorphism like operator overloading, function overloading, and there is also the feature of inheritance. And within inheritance, there is a specific feature which is used during inheritance. It's a virtual function. Okay, so these together forms inheritance, and this particular feature is also this particular feature is also an example of runtime polymorphism. And these are mostly examples of compile time polymorphism. Okay, and these combined together are the features of C++. Okay, so this gives a idea of the type of topics that will be covered in the C++ while talking about C++ and as a language, and also some of the object-oriented features that we have discussed during our introductory classes. Okay, so as you can see that it includes everything that is there that was there in C, and that included the notion of structure and all this, structures, loops, function declarations, and all this. But then it supports C++ supports encapsulation, where you can put together the behavior or functions along with data, and we can have specific access specifiers in terms of private, public, protected. Templates are supported. Polymorphism is supported in form of operator overloading, function overloading, and virtual function. And this virtual function is actually used while implementing inheritance in a more flexible way. So it has got some bit of overlap. So that is the overview of the features. So we'll be looking into it one by one. So the first code that we started discussing was temperature conversion from Fahrenheit to centigrades, and this was the C++ code. And the first we expect the header files to contain predefined classes, predefined class templates, predefined uh, functions also, because isolated functions are also allowed in C++ in contradiction to Java, and where you may not be able to or you are not supposed to write isolated functions without encapsulating it within a class. But in C++, it supports to have isolated function declarations or definitions like C also. And in addition to that, C++ libraries uh, or these standard libraries do support or do provide some predefined objects. Okay, even the instances of the classes are also created for ease and for faster programming. So we'll see what is that. And the second point that we pointed out was how we write the main. So in C, even if you write main without specifying anything here, it will still work. But if it is a pure C compiler, but these days all the compilers are more or less C++ or C compatible C++ compilers. So if you write something like this, you will get a warning message that you should not leave it as blank or whatever. So you are actually expected to specify here void if nothing is there, if no argument type is there. So you should specify explicitly the void data type without making it ambiguous and without making uh, mm, I mean, so it's a good practice that you start doing things right from the beginning. So whenever you write a function, if a function or method does not accept any argument, do write void there. Don't leave it as blank. Okay. So this is required because C++ implements, or object-oriented programming languages implement function overloading, what we found. And function overloading is basically developed based on the underlying say notion of, say, multiple functions having the same names can be differentiated by in terms of number of arguments that they accept and the type of the arguments. So type checking of the arguments is a very critical uh, mm, point when the compiler compiles a object oriented program or object oriented code. So these object oriented compilers are often called as strong type check compiler. Okay. So because of strong type checking, you are not supposed to, or you are not allowed to leave anything as vague. Like void means you have to write void. At the same time, we'll see later on that when you overload functions, you should not create unnecessary ambiguity while overloading. So even if some int and some character they differ in the type, but when you call those functions, in fact, both are allowed uh, simultaneously. So any inherent ambiguity which was supported in C or maybe in C++, so any inherent ambiguity while you overload a function should be avoided. So it is not only strong type check, but it also will not allow any ambiguous calls to make. Otherwise, the compiler will be in trouble resolving which particular function body you you intend to actually invoke or execute. Okay. So up to this part, was it clear?
Yes, sir.
Yes, sir.
Now, so
Yes,
now
sir.
let's come to the, so what is the other very trivial point to note? The difference. We are pointing out the differences between these two. What is the other difference?
Printf.
In terms, in terms of declaration, in terms of declaration of variables, can you see something here that is different from here? What is this?
Main variable.
You
Hmm?
can declare any variable at any part of the
Any part of the, so that is not,
The
so
CS.
so that is different from what we have done in C. In C, you have to have the all the declarations made in a function, all the declarations made prior to any executable statement. So once you have done all the different declarations, only then you can start writing the uh, actual statements. And if you have to write, if you have to define something, you again have to move up and define it here like that.
Sankari, betul?
Hello? And here you can define it as and when required. So here probably when you are trying to convert, you want to create a variable centigrade, which should be of floating point type. So you can declare it here and you can keep using, start using it here. So the only advantage is you don't have to move up. If it is a very lengthy function of say 200 lines, you don't have to move up every time you find a new variable need to be declared. Or maybe you'd like to search the name of the variable. You don't have to move up and down like that. So this kind of flexibility is allowed. So the third thing is, although it seems to be trivial, but when you write codes, it becomes really useful. In C++, the variable names or variable declarations may appear anywhere in the function body. And here all function declarations must be in the beginning of a function declaration definition. Okay, so this is a seems to be trivial, but this is also a difference. What else can you find out here? Okay, if I look into the line 16 of C++ code, do you find any subtle change apart from the function, the variable declaration? I
Yes,
think,
sir.
yeah,
In
I
in
think
C++, float
see, the
typecasting is used on one parameter,
okay,
and
let me
like
first.
on far minus 32, but in C, the typecasting is used on the whole expression.
Hmm? Just a minute. Now, which one do you say?
So in C, the typecasting is used on the whole expression,
Hmm.
and in C++, it is used on only the far minus 32 part.
Yes. So the type of the way the typecasting is made, the typecasting syntax, it is different. So both are allowed, but it is more of a function type typecasting. So this typecasting pattern is a bit different. So typecasting syntax is different. So you can write here int or float, and then you can write it like this. Instead of float, instead of float x, you can write like this. Okay, so this is more like a, so as if this float is a function name and this is the argument, it is something like that. So the typecasting is syntax is a bit slightly different, but both are allowed. Now what other changes do we find in line 12 and 13 of C++ code?
Printf and scanf are replaced with
So
cout and cin.
printf
C in
and
and C out.
scanf
So
are
that
replaced
is,
by cout scene.
so C in and C out. And as you can easily decode, so C out, it is used in place of printf, and cin, it is used in place of scanf. So cout is meant for displaying the entire Fahrenheit, that uh, that comment, and then scanf, and then cin is used to read the values for the variable Fahrenheit. Okay, that we generally do using scanf. So we already mentioned. So what is printf and scanf in C? So this is say number 4 and this is a number 5. So what was printf and scanf in
Function.
C?
See out. And so
So printf, scanf. So both of these are library functions, right? And where they are found, where these functions are declared.
Stdio.h.
And here in contrast of printf, we have got cout. And in contrast to scanf, we have got cin. So what are these? Cin, cout.
Objects.
These are predefined objects. So this is something need to be uh, noted from the beginning. So these are predefined objects. So in C, do you ever find that a library function contains some predefined variables? Have you ever found any library function which
no, sir.
contains not only functions but also variables are also there? It was not there at all, right?
No, sir.
But in C++ and the analogy to a variable is in C++ is an object, right?
Yes, sir.
What was a variable in C was an object in C++. I mean, similar. So, and predefined objects are there in C++. In fact, in iostream.h, we have got the C in cout. Okay, so that's why we just include here iostream.h, and in this case it is stdio.h. So iostream.h comes up with the declaration of predefined objects cin and cout, which is also used here like this. So you don't have to. So the point is, so if these are objects, so objects are instances of a particular class, right? What are objects? Objects are instances of a particular class. Do you accept that?
Yes, sir.
Yes, sir.
So this cin and cout must also then be instances of some classes. So which class do they belong to?
Output stream.
So they also must be an instance of a particular class because these are predefined objects. So which class they cout? Yes. So this is O stream. So this class, we'll see later the use of this class, but this class is called O stream. So this O stream is a class, and definitely it is a predefined class, and cout is just a predefined object belonging to this class. Similarly, this I stream is again a predefined class. So these are predefined classes, right? So these are predefined, these two are predefined objects, and these two are predefined classes, each belonging to this class. Is that okay? And all of these are found in iostream.h. That's why you need to include iostream.h where we write our C++ codes, because we prefer to use, instead of printf scanf, we prefer to use cin cout because of several advantages. We'll look into it. So is that part clear?
Yes, sir.
And again, those who are doing C++ for the first time, at least you you are familiar with through our discussion what is a class, what is an object, and why we need to define and declare classes and instances of classes as objects. So this iostream.h, sorry, iStream and oStream. So these two are classes, say for example, and these two classes are actually subclasses which are derived from a parent class or another base class. Do you know what the name is?
iostream.
It is iostream class.
iostream.
So you can, so because this iStream and oStream are actually subclasses of this, so we can write this. Is that clear? Just try to recall the relation between different classes. So what kind of relation they hold? So iStream is a oStream class and oStream is also a iOStream class. So what kind of relation they actually bear?
Is a
So this is an example of, so this is an example of what? What type of feature that we discussed?
inheritance.
Can all others relate to this in terms of the discussion? That's a
Yes,
phone,
sir.
smartphone from the phone, and then all those things, right? So there are two ways classes can be related. One is a relationship, which is actually modeling inheritance, and other one is has a relationship, which is actually modeling the composition type. And this is an example. So what I mean to say is, see, we have not written a single piece of, we have not explicitly declared a single class definition, right? In this C++ code, did we? Neither we have specified any kind of inheritance, but you can see that using these predefined objects seen and see out, you are actually using some class definitions, and those two classes are actually inherited from another base class iostream, and this is all there. So this particular class design, it has been already defined in the iostream.h. So this iostream.h, this includes all these details, and not only this includes these things also, like iStream. What is object? Predefined object corresponds to iStream.
Cin.
Cin. Okay, so it is something like this, and oStream cout. So this entire, this entire definition is there in iostream.h. And because of this, you can just simply write C in C out, because it is all there. Not only the class definitions are there, but also the instances, one instance of each class is also there. So what is the purpose of this? As you can see from this, what is the purpose of C in C out? So these are objects that is known. What is the purpose? They are meant for, what is the purpose? Here also it is used. What is the purpose of C in C out?
Taking input and output.
So here, okay, what is the problem? So it basically takes data from an input device and copies it to the buffer. Buffer means the storage from where you can start processing, and it also is useful to uh, pass on data or information to the output devices. So what can be the input output devices? So if this is the external world,
Keyboard and monitor.
hello, hello,
Yes, sir.
hello, yes, any problem?
No, sir.
So if this is the external world, so we have got, and this is the machine. Okay, so this is the our machine buffer. Buffer is what? Buffer is a small storage space, maybe a set of registers and all this, or some memory location where whenever you read something, you put it in the buffer first. You copy it in the buffer. and from the buffer only you take it for processing. And then there is another buffer after getting things processed. If you would like to pass it on to the external world, you first drop it in that buffer, and from that it goes to the external world. So things, when it gets first copied into this machine buffer, we call it as an input buffer, right? And when you before you dump it in the external world, you basically copy it in the output buffer. So the see in and see out, these objects facilitates the transfer of data from the external world to the machine and vice versa. Okay. So what can be the input in the external world? What can be input devices from which you can read or you can seek data from?
Keyboard, mouse.
And what else? It can be files also, right? So from here you are taking data, from here you are taking data, and from files you can also, so you are having something in a file, so that is also stored in the secondary space, I mean secondary storage, and from there you are taking inputs. Sometimes you enter input from your keyboard, sometimes you enter input through by clicking a mouse button, or sometimes you are even ask your program to read data from some files which already stored the data, right? So which object facilitates this? See in and see out. Which one? Which predefined object
See in.
facilitates?
Let's say in.
So see in facilitates. So you just have to recall this, that scene, the scene objects helps you. Now there is another thing. So what is this one? So scene. So before you, sorry, the scene far. So far is a variable, Fahrenheit is variable. So through scene you are reading whatever you are typing in the keyboard. It goes to the, it gets stored in that particular variable, right? It gets stored here. So what is this in between? What is this?
Operator.
This is an operator. Everybody knows it. Even the C coders, they also know this is an operator. So can you recall what was the purpose of this operator in C when you didn't, when there was no idea of C++ for you?
Right shifting.
Hmm?
Right shift operator.
This is a right shift operator. So this is a right shift operator, and in this case, this operator. So this was originally, I mean, as you know, it was a right shift operator. So what kind of right shifting? Which actually, what it shifts?
The bits.
The bits. So it is bitwise right shift operator. So the individual bits that is stored in the memory, that gets shifted one place to the right, and same as this was a bitwise left shift operator, right? So these are already known to you. Now can you see that this operator, which was used for right shifting of the bits, now is helping you to extract the information from a keyboard or mouse and feeding it into the buffer through this object. So this operator, can we say this is an example of overloading of operator?
Yes, sir.
Yes, sir.
So this was already one role. So this is some role of this that we already know. So this, if this is role 1, this is now another role, role 2. What is role 2? Is to go for extraction of input information, and using this object you are doing things. Similarly, when you are trying to pass on something that you would like to display in the external world, what are the other kind of what are the actual devices that you have here for displaying?
Monitor.
And
Screen.
what else? Monitor, and then printer, right? And then scanner, sorry, plotter. Scanner is an input device, right? So when you are scanning, so scanner is an input device, right? And what else you can have? Files can always be used, can be considered as an input or output device. So from the files you can, so you can pass on the output and store it in a file. You can pass on the output and plot it in a plotter. You can display it in a monitor. You can also print it in a printer. Is that fine?
Yes, sir.
Yes.
And what is the object? Predefined object which facilitates you? It is the cout object. And what is the operator through which it solves does it? It is this operator. So this is another, this operator which was earlier used as and you know that it was a left shift operator. Now it has got another role, and that is meant for, if it is extraction, what we can say, it is for insertion operator, insertion of output information. Okay, because you can see that the cout, so this entire Fahrenheit, this entire string, uh, enter Fahrenheit, it gets displayed in the monitor. It is exactly equivalent to enter Fahrenheit if we ignore this /n/t and all this. So this how it is done. Not only this object but also this operator is involved. So for dumping output to the output device, we require this uh, insertion operator and this cout predefined object, and then whatever you write will be displayed there. For extraction of input from the input device, you require this operator. We call it as extraction operator. It has got other purposes in other scenario, and it uses cin for doing this. So is that part clear?
Yes,
Yes,
sir.
sir.
So you see, without writing too much, we have already started using many of the C++ features that we are trying to illustrate through several real life examples, right? So by this time, what are the features that you have already identified and you are probably using without noticing it?
Inheritance. Polymorphism.
So inheritance is, it's there, and these are examples of operator overloading, right? So this is one kind of polymorphism you already started using without knowing it. And there is the existence of objects and all this. So these are all there. So even in this very simple C++ code, you don't actually write explicitly things, but you are indeed using things like that, right? Apart from some syntactic difference, that like the comment lines can be you can have single line comments instead of block comment. You can have flexible variable declaration. You have got these features also. Is that okay?
Yes, sir.
Yes, sir.
So can you point out some other interesting feature in line number 18 of C++ code?
Sir, end line.
Hmm?
Sir, end line is used.
Yes, end line is used. So what is the purpose of end line? So the purpose of end line, because I have not run the code, this purpose is same as that of, okay, so let us talk about endl, endl. So endl, so this we label it as the difference 6, right? So this endl is difference 6, is a 0.6. So what is this endl? What is this called?
Object.
Okay, any better answer? Those who are C++ coders and experienced coders. This is very simple. I mean, immediately you can.
Slash.
No, I'm not talking about the purpose. Endel, it is equivalent to writing
And
slash
array.
n.
Slash n, sir.
Yeah, that is equivalent to writing. But what is endel? I'm not talking the purpose of endel. I'm talking what is endel.
Sir, it can
To go
provide
to the next
automatic
line.
F flush, sir. It can
No,
provide
no. Again,
automatic F flush.
just listen to the question. What is endel?
It's a function.
Annotation.
Object.
Manipulator.
Object of host tree in
Yes.
class.
So this is not an object, not a class, not a function, not an operator. This is a
Which
A macro.
Yeah.
to the next.
this is a manipulator. So I think one of you answered, but many of you knew the answer, but probably didn't notice it, right? In C++, those who know C++, manipulator, have you heard the term? How many of you have heard the term, manipulator? How many of you heard the term?
Yes,
So
sir.
now, yes. Any answer?
Yes.
So manipulators, so what do they resemble? Manipulator, is it a class? Is it a function? Is it a operator? Is it a, what is that? What it resembles? So manipulators, we'll talk about manipulators today in the sessional class in more details. There will be one lecture on that. But manipulators, you can say these are special functions. I mean, these are some kind of, so these are not functions, but you can treat them as special functions because sometimes, so this is a manipulator. Sometimes you have got some manipulators like, we'll use it extensively, like set W. Have you used any of you used set W? Anybody
Yes,
of you
sir.
used set W?
Sir, we have used set car and get car.
So set W, what is the purpose? We'll see that. So manipulator, the first thing, why we call it as manipulator? Manipulator is used to manipulate your output in the display screen, right? So this is a display screen. When you are trying to display 50, so you write 50 here, or you give some leading blanks and then write 50. Okay. If you are writing 123.5972, are we going to write it as 123.6, or are you going to write 123.5, say 598, yeah, 59. So the precision of a floating point number, the say 50, I can write 50 like this. I can write 50 converted into hexadecimal. That also is possible. So whenever we are writing something, whenever we are trying to display some values, some inputs, some strings in the monitor, we sometimes need to manipulate it so that it looks good, it looks in a nice formatted way and all this, right? So to manipulate the output, what we use, we call it as manipulators. Is that fine?
Yes, sir.
And this endl is also doing so. So instead of writing it in a single line, you give endl, so that the next output will start from the next line like that. Okay. For giving the tab also, we can have some manipulators used for that. So tabs are meant for giving some blanks, right? Blank spaces. So that also we can do. So there are a list of manipulators which is supported by C++, and they are all found in a different header file. What is that? Do you know? Like
IO
endl is
IO
there.
menu.
Yes, so endl is so common. It is so people said that, okay, so the designers thought that, okay, let us include it in the iostream.h header file itself. But there are certain manipulators, if you would like to use it, like setw and all this, and you can see the difference. What is the difference between endl and setw? What is the basic difference?
So set
It
W is
accepts
to
an
specify the
parameter.
end L is end of the line to insert a new line character.
So it is taking an input
Sir, Endel
parameter.
can also flash the output directly. So
No, are you getting the point? The point that I want to highlight. This is parameterized, right? And
okay,
this
it
is
is
not
parameterized.
so
It is
it is accepting a parameter, an argument. So that's why sometimes you can think that these manipulators are something like special functions, but these are not functions, but these behave like a special function. Okay, because as if a set W is a function and 5 is an argument which says that how many blanks you need to give preceding blank. I mean, say yeah, preceding blanks you would like to give before you display some value. So there are a whole lot of manipulators, a set of manipulators that is supported by C++ compiler, and these manipulators are, some of them are parameterized, some of them are non-parameterized. They just need the name, that's all. And some requires more than one parameter also, but these are not functions. So it appears, looks like a function, but they are not functions. They are better and always known as manipulators. And although some of the simple manipulators are available in iostream.h, but the most of them and the rest of them, they are found in is that fine? Hello.
Yes, sir.
Yes.
So IO many, and you can see that from the name itself it appears. So input output manipulator IO many dot h. So this includes the entire set of manipulators which are parameterized and all this. But in this case, you see, we didn't include that because Endel, the only manipulator that we have used, it is found in the iostream.h. But if you would like to have a much more manipulated output, which much more flexibility and few more, probably you sometimes need to use iomanip.h. We'll see that in our next class, right? So these are, we can see the differences becoming evident. Now, can you point out the next difference in that line 18?
The format specifier.
Yes, format specifiers are not required. That is fine. That is advantage of C out and C. That is fine. So we can list this also while we are writing C in C out. So while we are writing, okay, let us write it here. What are the advantages of using C in and C out over what is the equivalent of C in?
Can.
What are the advantages? Can you figure out one by one? Just looking into this. See, scanf, what I need to mention here? %d. Do you need to write it here? %d.
no, sir, no kind of identifier is
In
required
this
for the both.
line number 19 in the C code, in the line number 19, you see, in this particular C code, to display this Fahrenheit, I would like to specify %d. For this centigrade, I would like to write %f. So what are these called? %d, %f?
Format
Format
specifier.
Format
specifier.
specifier.
Format specifiers. Do we need to use any format specifiers here?
No, sir.
This is not
No,
required.
sir.
So this Fahrenheit, so when if FAR, it displays some say integer value, it displays some say floating point value. So, and while reading also, even while reading or writing, or while you are say trying to read something and write something from the external world, you do not need any format specifiers while using C in C out. Is that fine? Can you conclude that?
Yes, sir.
So
Yes, sir.
first and the most, and that is quite uh, useful. No use of And in fact, in while writing, reading C programming, this is one thing that many of us, found it really difficult to recall, and then sometimes you miss out and you get into trouble and all this. So sometimes, say while displaying an integer and a float and a character and another integer, four things, maybe you have specified three format specifiers, right? So while you are displaying x, y, z and say p, so these are the four things. And in the format specifiers, you mention only %d, %f and %c. That only. What do you think? Will it stop compilation or will it work? There are four variables. You specified three format specifiers. Will you think that it may always give a
No.
compilation error, or it will just give a warning and will do something?
Error.
One.
Sometimes gives a warning in some compilers. And another nightmare is x probably is a float, but you have, maybe you have misplaced these two. So first you have written %d and %f, and you really don't know what to do. So recalling these format specifiers, which one is for int, which one is for long int, which one is for long int, which one is for pointers, which one is for unsigned int. So this recalling this entire list of format specifiers and trying to use it in a proper way, in a proper sequence, is always a burden. And if you miss it up, or if you mess it up, you get outputs which you cannot decode. What is this, right? You cannot figure out whether the program is correct or not. So this is something very advantageous when you use C++ and use simply scene and cout, where so the scene cout object, it is intelligent enough to figure out what particular type of variable you are trying to read or write, the value you would like to write. Is that okay?
Yes, sir.
So that is really really useful. And in fact, what we say, this is easy. We can, so can we call it as easy means easy to use, and at the same time, can we call it as safe?
Yes.
Safe means, you see this integer and float. If you have, so if this was actually float and this was actually int y, but you have just you have swapped the format specifier, so you would get something that probably is not correct. So it is unsafe, and it is up to you to, but there will be no error message displayed, because %d, it will display that. So it is not checking whether this matches with this matches with this. So there is no check. Even if there is checking, it just gives a warning message, that's all. So the output sometimes you get is not that you want. So this is not only easy but also safe to use, right? Because it is not the responsibility of the responsibility of mentioning the specifier of a particular type is not in the hands of the programmer right now. So that's why it is safe. So compiler says that, okay, you just write the variable name, I'll figure it out what type it is, and accordingly I'll display. Is that okay?
Yes, sir.
Yes.
So actually, we have a class from 11.
Okay. Just one last point. So like this, if I have got a matrix class or a complex class, so these are not predefined, right? So you probably have written it. Now you can think of writing scene what is this? So using the scene standard input object, you can read the elements of a matrix also. So the point is, so the scene cout, you can overload this operator for user defined classes also, and you can write here cout m2. So this use of scene cout is not only valid for only the predefined classes like integer, float, character, string, and all this, but this is also valid for any user defined classes or the new classes that you are going to define. So you can extend the idea of using C out to display and read objects for new classes that you are going to define. So this is in some sense adaptive. You can adapt and extend the definition of out, and you can overload those extraction and insertion operator. Is that fine?
Yes, sir.
So you can say that this is easy, safe, and adaptive. So from now onwards, while we write C++ codes, we'll never use printf and scanf. So that will be the end of. So printf and scanf should not be used anymore, at least for displaying and reading in variables and displaying variables. Okay. So that is the end of the class. So I'll take in the sessional class today, in the second half, I'll basically focus on discussing about more on manipulators, and there'll be one more feature that I'll discuss about this first code. If you have any questions, you can ask. Otherwise, I'll leave. Any
So
questions?
there is one request, like, sir, can we just stick on to with the like 45 minutes thing of the classes? Yeah, or yeah, even in some cases we can make it to 50 minutes because we are not getting much
Okay,
of a break
so
between the
the
classes.
simple thing, give me the warning after 50 minutes. Because after
Okay.
warning, I'll maybe take another 2 minutes. I understand switching from
Okay.
one class to another, although it is in an online mode. So give me the warning after 50 minutes. Okay.
Okay, sir.
Hmm.
Thank you, sir.
Okay. Okay. Thank you.
Thank you, sir.